Hi everyone, this is a very short video I wanted to do about the paper I just read from Carl Brans. It was published right after the Brans-Dicke theory in 1961, where he discusses Mach Principle, and it is available for free in the description of the video. Follow me in reading his introduction, where he starts talking about Mach and the ratio between inertial mass of a body and the active gravitational mass. He says, let us see what this ratio might be in a static universe considering only a mass shell of radius big R and inertial mass big M. This will be the mass and size of the universe, together with a relatively small body of inertial mass small m and a test particle. I quickly made a picture to understand this thought experiment from Brans. We expect that the acceleration of the test particle is independent from the mass of the test particle itself from the equivalence principle. Then he continues stating that the acceleration certainly depends on the mass small m, and because of Machian arguments about the inertial properties of the test body being determined by the distribution of matter in the universe and not intrinsic of the body, it can conceivably also depend on big M and big R, the mass distribution of the universe. We explained Mach Principle in our previous video, Mach Principle Explained. He puts this into mathematical form with the simple equation shown here, and as we all know, he relates the function f containing the mass and radius of the shell or of the universe to the gravitational constant, so that the equation here is literally the usual gravitational acceleration equation from Newton. This is the justification for Brans-Dicke, in which the gravitational constant depends on the potential of the universe and the scalar field of Brans-Dicke, etc. We covered Brans-Dicke theory in our previous video, Einstein's true reason for the cosmological constant. By the way, the speed of light here is missing because it's set to 1. Don't forget about the equation he comes up with, but before showing you why it is important, let me explain why general relativity is not Machian. An analogous case of Newton's shell theorem, by which for a spherically symmetric shell, no net gravitational force is exerted by the shell on any object inside, happens in general relativity by Birkhoff's theorem. This means that the spacetime inside the shell is the usual flat Minkowski spacetime, in which there is no gravity or any modification to inertia. The dynamics inside the shell, contrary to Mach's ideas as correctly pointed out by Carl Brans, do not depend on the mass of the shell. As a reminder, the shell is a simplification for the boundary conditions of the distribution of mass in the universe. But now let's consider 1983's MOND for Mordechai-Milgrom and the equation that Brans worked out. We explained MOND in our previous video, Does MOND Work? And evidence for modified inertia. Actually, MOND has an equation for the acceleration of a test particle at a distance small r from the mass small m, in which Milgrom introduces to the usual Newtonian acceleration an interpolating function based on true acceleration and an acceleration constant. But the acceleration constant matches the gravitational acceleration induced by the universe, and the true acceleration can be substituted by the Newtonian field intensity, so that Milgrom's acceleration equation is the usual Newtonian acceleration with a function f depending on big M, big R, small m, and small r. I also set the gravitational constant to 1 here. And look at the similarities between Carl Brans' Machian acceleration from 1961 and Milgrom's MOND. They both imply that local dynamics are governed by the mass distribution at large. But notice that while Brans' motivation is theoretical, Milgrom's motivation is empirical, because MOND correctly explains the dynamics of galaxy rotation curves. The important question now is how to implement this Machian effect into a relativistic theory. Brans-Dicke failed because it modified gravity in the high acceleration regime, where we know gravity strictly follows general relativity. And regarding MOND, Tevez has shown problems and it loses the power of its simplicity by the addition of the scalar and vector fields with corresponding new parameters. In this channel you will find our journey towards a successful modification of our understanding of gravity for more than 1 year, and many more interesting topics explained. Thank you very much and see you in another video here in Independent Physics.